reviewing some of the stuff from last class. So what I always like to do when you think about like reviewing different databases, different technologies, and you've heard me say this I think a lot of times, is just like, okay, how does it offer like something new in our lives? Like how does it make our lives as data engineers any better? So if you think about it, we could start with like Redshift, down to Snowflake, and then to Spark. So with Redshift, right, it's like this distributed database that scales compute as computing power, as data scales, and right, and it does like naturally, partitions the data, right, MapReduce. Like there are more things, like we talked about like more things, but in terms of just like the benefits, right, these are the main benefits that I guess for me come to mind immediately, right? Then for Snowflake, the first thing I just think of is isolated compute. But even if you don't remember that word, what you're thinking of, okay, well, there's this problem with just like scaling the computing power as the data scales, which is that the computing power is what's really expensive. And, sometimes maybe you don't want to pay for all that computing power. And it's not that, as one scales, we need to scale the other one, in line, right, proportionately. So this allows us to kind of scale up or down our computing power, computing/memory. Yeah, you could really just call it the computing power or compute, independent of the data. And then the last thing I would say is like naturally, cloud-based. So I'm just always thinking like storage is on like S3/blob storage, and then compute is on like EC2 machine or the Google equivalent. Okay. And it does a bunch of fancy, if people are like, is that it? Well, no, it does a bunch of other fancier things, right? It has this like micro partitioning for us, which has these benefits of it automatically partitions for us, both by row and by column, and it's partitioning, right, in kind of partitioning the data in Snowflake. So for fast lookups, and remember it also has that services layer, right? So so if they ask about, if this comes up, right, or if they ask for more kind of benefits, right, it will cache queries for you. It will try to do some query optimization, meaning we'll look for like faster ways to execute the query for you. It will access this partition to identify where to go to. So right, it has a bunch of fancy kind of features in Snowflake. But this is the main one that I would focus on, this isolated compute. And then Spark, the main thing I think of is just in memory, like that's kind of the main thing. And this actually offers you a lot of benefits. So if it's like, when would you use Spark? Maybe that's the question, like when would you use Spark? And it's like, well, to quickly query like unstructured / semi-structured data. And why do how does memory fit into that? Well, because the storage is in memory, right? Like we can read in the data without setting a schema first, right? Because you just do like spark.read.csv and then point it to your S3 bucket that you want to read from, and that basically returns to a pandas data frame, or not a pandas data frame, but a Spark data frame, but something kind of equivalent to one, and from there you can query that data. So it's like, this is like, when would I use Spark? Well, like, yeah, if I want to read some unstructured, semi-structured data, right? Like if we're just storing log files in S3, if we have some like API calls, right, or like a data lake in general in S3. right? Then and I want to read it. You could maybe as an alternative, remember Athena? Use Athena because that also just like allows you to query S3, but this is faster, and so then how is this maybe even faster than Athena? Well, it can be like a cluster of compute, and also does use this like MapReduce in general, and it will like partition the data. So you're getting a lot of these these features of Redshift, Snowflake, except that they're occurring in memory. It's partitioning the data in memory. It uses cluster of compute. It will perform MapReduce, right, with on your in-memory kind of storage. And once you're done, then you just shut down the cluster, and the data is stored permanently in S3. If you want to write the data, you can save it in S3. Okay, so it's like this is just I can send this to you if you but I think the main thing is you want to go through this yourself. Like you want to quiz yourself on this, and like when you're kind of reviewing or quizzing yourself on any kind of architecture, just always think like, why do we need this thing at all? How would our life be any worse if we didn't have this thing? And if you can't answer that question, ask ChatGPT, Google it, right? Like just like, what does this have to offer? Okay. All right. The other thing I wanted to show you was actually just another like kind of jobs before we move into SQL stuff. Was just some more like jobs board list, because if I was thinking for you all like how to find these positions that are not listed everywhere, what I would do is think about kind of again like your unique skill set, right? Like say it's like health tech, and then what you might do from there is look up like top health tech VCs, venture capital places. Okay, and so then you can find these. So you can get a list. So it depends on what what your skill set is. It could be different. Maybe it's AI. Maybe it's I don't know. Varies based on the person. But in one way to think about that is think about like where are you getting responses from recruiters or from when you apply. Like how is the market seeing your skill set? And so if you're getting like, okay, it seems like this is an angle for me. Well, now we have like a list of these different VCs. Okay, and I would actually start at the bottom because we're looking for like more obscure ones, and you can see that like seed funding and Series A. So the like it goes in order of like Series A funding comes right after seed funding, right? Seed is like the initial few $1 million, whatever it is. Then comes Series A, then Series B, etc. So you're really like I'm looking for like seed and like Series A. Right, or like it could be something like this because it's obscure, but I'm just looking for like kind of smaller funds, and then I clicked around on a few of them, and I just for each one that seemed relevant, like I was just typed in. You can see I did it for a few of them. I got up to 6, right? So I did it for 6 of them, and I did something like 55 years, and just typed in jobs or VC jobs, and then that took me to this. Okay, and then we can find the job portal, right, of the VC, which is really nice because it's a collection of startups, right, that are at a similar spot. You can even search by this, but I wouldn't at the right away. I would just type in like look for the roles, look for the skills. So you might type in something like data, right, or you can just literally do like software engineer, and then just start to explore. And I mean, some of them are senior, but I also found like this is pretty good, right? Like DevOps engineer, intern for flight. So that sounds interesting. Flight software. Like this is going to be too senior, right? If you're the ML, and you can also get a sense by the salary. But if it's something like 105, this one it says full stack engineer. The salary's a little high, but not extremely. And the other thing to look for is those that are posted relatively, not always, but like if they're more recent, then it's a little bit better. And you can probably, I'm sure you could filter by things like that too. All right, like posted any time, the last 1 month, etc. But it's just a way for you to prioritize. And remember, from there, you can use this like simplify jobs thing to be able to apply relatively quickly. And then if you find a place that seems like, maybe you find 2 or 3, maybe you apply to like, 20, and you find like 3 to 5 that are good fits, that you really think are like good for you, I would try to reach out to the hiring manager, right? Like try to write them an email or something to get back to them. Does that make sense? So this is good because the idea is you want to figure out like what your kind of niche is, right? Like for me it would be like legal tech, right? Because I have a legal background and now I'm a software engineer. And like when I look at recruiters who have reached out to me, who have like some co-founders have reached out to me, it's in this law. Even though I don't think of myself as a lawyer, apparently the market does. So like I'm gonna use that, So I would do like legal tech and then that. And then the same thing, some of you guys maybe you feel like you don't have that kind of background, but I would play it up. Like if you have worked in a health care like field or something like that, I would, position your LinkedIn profile to like play up that kind of niche. Like you could just put like health tech data engineer or something like that if that applies for you. And then, when you reach out and they click on your LinkedIn, hopefully they'll see things like that. All right. So that is one thing to say is like doing any of this stuff, like reaching out personally, applying to these niche places. Just remember, like the first thing they're going to do is click on your LinkedIn to like verify what you're telling them. So if you don't, it's like a prerequisite essentially to like have cleaned up your LinkedIn to position yourself. Any questions about this stuff? I think that it's a pretty good strategy, right? Like to look at these, starting with VCs, then going from the VC to the job board, right? It took me like 5 tries to find a good job board, but that whole process took like 15 minutes. And now we have a bunch of different positions. A bunch of different positions that we can look through, and they're and work on. All right. Cool. All right, and then the last thing I was going to do is go through some SQL LeetCode. That's what we can do. I know that some of you guys have internship stuff and things like that, but if you aren't otherwise busy, that's what I recommend doing is like continue on, review some of the Spark stuff. I left some Spark discussion questions I'll post. And then there's this gameplay SQL question, right, that I posted before. So I was going to review that, and then there's some more, and I have the solution here that you can look at after trying it. And then there's a couple other LeetCode problems that we can go through if you have time. But let's review these. I'll just review a couple of these. I've gone through these twice now because in preparing for talking to them for you guys, and both times going through them I struggled. So I think they are, even though I just saw it 3 days ago. So even if you've done it, I think that it's worth going through again. Because I also do think that they're pretty good problems. Let's see if we can figure it out. Write a SQL query. So first of all, you can kind of, just to tell you what the data looks like, you can see that we have this player ID, what device it is. So imagine like they log into a website and maybe they're logging in on the phone or their computer. I guess it's playing games. And how many games do they play? So let's imagine they're playing chess or something like that. And then event date, right? The day that they logged in. Okay. Write a SQL query to report the fraction of players that logged in again. Logged in on the day after they first logged in, rounded to 2 decimal places. So it's like retention type of thing. What is the percentage of players who logged in again on the day after they first logged in, rounded to two decimal places. In other words, count the number of players that logged in for at least 2 consecutive days starting from their first login date. Oh, really? For at least, 2 consecutive days starting from their first login date. Then divide that number by the total number of players. All right? So first of all, it's like, can we just answer this thing? If you look at it, we have this player. He logged in March 1st, and then he logged in again on March 2nd. So this would be one of our people, right, that did log in on consecutive days following his first login date. Then we have, let's say, player 2 only logged in once, so they don't qualify. Player 3 logged in like 4 months later, like 2 years later, so they don't qualify. Okay? So I think it's just 1/3. Out of all the players, we have 1, 2, 3 players. Only one of them logged in consecutive days. All right, so that's the answer we're going for. All right, so from doing this problem, what I kind of saw was we're going to need a window function, right? We're going to need, or we're going to need a CTE, and then in that first CTE, in the CTE, we're going to want to like coerce as much data as possible. Like perform as much coercion of our columns as perform all that up front. So it's very much almost like the way we code SQL, like transform our data first and then kind of query it. So think about what we need. We want the first day a player logged in, and what's the next day maybe they actually logged in, and so it's like a few things. So let's think about it. So we'll have the first day the player logged in. So we can call this sign up day. The sign up day plus 1, right? Because we want to figure out, did they log in again after that? So let's just have a column of that sign up day plus 1, and then we'll have a third column of like next login day. Okay, the next login day. All 3 of these we actually can calculate, in that first CTE. So let's do this. We'll call this I don't know. I don't have a good name for it. I'll just call it with event stats as, and then select all from player events, select all from event stats. So all I'm doing is this is my original table, and now I'm just querying my CTE here, so that I'm not changing anything at this point. Okay, so now I'm going to want to try to coerce this stuff. So the first thing is the day they signed up, right? So for this player 1, it would be March 1st is their sign up day, right? And we can have, for this player, they only have 1 day. For this day, it's March 1st too. Okay, so how do we do that? It would be select the sign up day. The sign up day is going to be defined as, this is going to be the minimum of the event date, and it's going to be over partition by the player ID, right? Order by event date ascending. So this is, right, I'm using a window function. I'm partitioning by the player ID. I'm finding the earliest day, and then I'm going from smallest to large. I actually don't even need the order by. I don't even think I need this. Let's see if and we're going to call this my sign up day. All right, and then let's see if that works. So here we have March 1st is the sign up day, March 1st, even on this event, right? For player 1 is the sign up day, June 25th, March 1st, July, right? And it's still March 1st. So this is good. So this is the sign up day. The next thing we'll do is comma, the next day, right? Or sign up day after, we can call it. I'll just do as day after sign up. And we'll do the same thing, really. The minimum of the event date. You could do it this way. Minimum of the event date plus 1. And now I have to do Yeah, it's going to be a little annoying. So I'm going to have to convert this to a date. Then I need to do plus interval, and then it's 1 day. How do I know this? Just from these problems here. But this is a good thing to know if we're doing these problems. And I probably messed it up. Let's find out. I messed it up. Let's see. A syntax error at or near over. So I think I may have to do this afterwards. Let's just see if I can do it. I don't even have to do it this way. I could let's just do this for right now. I just want to try this interval thing. Okay, so this is working, I think. Event date, no it's not. Oh, day after sign up. Yeah, so this is giving me 1 more day. This is my event date. This is the event date, right? And so it's March 3rd. But now I want it actually, I could leave this. I think I could do this. Let's see. I wonder if I could do it like this. If we could do minimum of event date over partition by player ID. I wonder if I could do it like this. I'm not sure. Oh, that actually worked. It's pretty hard. Basically, I just redid the window function here, right? I made sure I coerced to a date, because originally it's a string. Coerced to a date, and then I just added a day. So I did plus interval 1 day, and that gave me March 2nd. So even though the event date is March 2nd, here the sign up day is March 1st, and the day after the sign up is March 2nd. Okay. So I think this is right for each person. The day after they signed up is March 2nd. Even doesn't matter if this event date changes the day after player 3. So I'll let you can kind of look at this. So I redid the window function, and then I just did plus interval 1 day as day after sign up. And now the last thing I want to do is, and by the way, before I forget, I want all of these guys, I want to make sure this event date, like all these event dates are actually dates. So I'm just going to coerce this to a date too. And then the last thing I need to do is find the next day they actually showed up, right? So for each thing, it can be like the next day they showed up, the next login day, right? Yeah. So then, yeah, go ahead, Conwell.
Yeah, I actually solved this GIF, but I did it using other approach. It's similar to this using a function like
Yeah. Let
over
me.
function.
Yeah. Let me finish this, and then yeah, we
Yeah,
can
sure,
explore.
sure.
So the next login, I'm gonna need probably one more thing, which is, I think I'm gonna want to have like a rank function, too. But for now, let's just do this one more thing, which is I want to find the next day. So for each event date, let's find the next day. So we'll do, how do we do that? We'll do a lead function, lead of the event date over, and then it'll be again partition by the player ID. Here the order does matter, right? Order by event date ascending. So I want to find for each row, find the next day they actually showed up. All right? And I'll put this as next event date. And again, I want to make sure I'm always converting to a date. That always throws me off. Okay, so this is pretty good. All right. The last thing I'm going to do, and I might have done something extra, I might have complicated this a little bit, is just a rank function. That way, this will allow me to filter to only care about the rows that are the first kind of event, the first time they actually attend. All right. So that's just going to be comma rank, over, and then it'll be the same thing. Partition by player ID, order by event date, ascending as rank or rank event. I don't have a great name for it. Let me see. Partition by player, order by event date, ascending. So this is the rank event, right? So this is the first the first time they showed up. This is the second time that player showed up. The first time this player showed up. Then we get to the next player, player 3, first time he showed up, next player. Okay, that was actually the hard part. I'll just pause for a second and let you look at this if you want to. I'm basically getting all the information I want up front. So this is like the first day they sign up, the day after they sign up, the next time they actually show up, and the rank event. And now just to make this a little easier, what do I care about? I care about on their sign up day, what is the next day? And then what is the next day they should be there, right? We want them to show up on March 2nd, and what's the actual next day? So let's just put a where clause here, where rank event equals 1. So for instance, this is everybody's sign up day. This is player 1 sign up day, player 2 sign up day, player 3 sign up day, and then what is the day after the sign up day, March 2nd? And then what is the next day they actually show up? This guy is March 2nd. For this person, they never show up again, right, for player 2. For player 3, they do show up again, but they show up in May, all right? So what's next? We can do something like this. And so where the rank event equals 1, and where, and the day after sign up, let's say event stats, I don't even really need that. The day after sign up equals the next event date. Right? So only this one should be returned as a match. Okay? And that's correct. And then I could do count star to get the amount of this. So this is one row, right? And now I want to divide this by all the number of players basically. So I could just do divide by player events, or this event stats, group by the player ID, right? Because I want to divide it by 3 basically. Or I could do either. So I'll do a subquery here, select all from, or select count star from player events, group by the player ID, and I broke it, comma, select all from, let's just do from event stats, maybe that will make it easier. And I still broke it. Let's see what it's complaining about. More than one row returned by subquery. Sorry about that. Why is that? Select count star from, this should just be one row. Oh, how do I do this? Because I want this for, this is a total number. This should only have one query. I think this should be, oh, this is just the total number of players. I shouldn't be grouping by the player ID here. Sorry about this. We want this to return 3. I know, we do want it to I can do like a count distinct maybe. I might have to look up the answer here. So this I have 1, and then I want to get the answer 3. I could divide by 3 and float it, but we need to do a subquery for this thing to be real. So how do I do that? Let me look at my answer. I'm going to cheat. But we got very close. Yeah, so I just did, I just did select, yeah, I guess I just did select count star. I just did the total number of rows in event stats where rank equals, basically just did this. right? Because there's only 3 rows where rank event equals 1, because there's only 3 users, and each user only showed up for the first time once, obviously. So we could do something like that, divided by select count star. We'll see if this works, otherwise we'll give up. From event stats, where rank event was 1. I'm not sure that does work. It feels a little complicated. There's probably a better way to do this, but I'm basically just trying to get the total number of players. So this is the first time that any of them show, that each player shows up, the first kind of show up, sign up day. There's 3 sign up days, right? And I'm dividing by, and I'm taking the number of players whose first sign up both, showed up for the first day, and the day after the sign up is the next day they show up. All right, so that's 1 player here, and I'm dividing that by all my players. Again, there's probably a better way to do this, but it's a hard problem, and this works. Lessons learned from this for me, like doing this, and I don't know that I won't torture you with this one quite yet. Maybe I'll do that later, at a later class or later today. But for me, lessons learned from this, let me show you just like a gotcha, which is if you forget to coerce this stuff to dates, all right, and then I'm like, okay, when does the day after sign up equal the next event date? And I don't want to, and I forget, here's the next event date, and I forget to convert it to a date, and now I press shift return again, it's going to break. And it says the operator, right, it's breaking because we're not comparing, we're looking for equality, but these 2 things aren't of the same type, because the next event date is a string because we haven't converted it to a date, whereas the day after sign up is a date. Okay, so it's going to just break here. So anyway, the point is, like, 1, I guess, just to see this error, and 2, you want to be careful about like enforcing type up front before, right, like up front, and that way you can work with this data when you reference your CTE. I did post the solutions here, so you're welcome to like try this stuff, look at the solution, then try it again. Like that's what I would recommend doing, because like I really think the only way to feel comfortable with stuff is by practicing it. You can see how tricky it was for me, even though this is now my 3rd time doing this problem. Let me see. I think there was a question, maybe. Yeah, we may not need that. I agree. I think Connor was pointing out that we probably don't need this minimum, this one, as the sign-up day, because we are reducing by it anyway. When we just say where the rank event equals 1, right? Because we're going down to this. Okay. So the first thing I did is just kind of collect all the data and rank the events, and by doing where the rank event equals 1, that's for the first day we attend, right? That's our sign up day. Okay, and then what do? We look for where does the day after the sign-up day, we calculated that by doing this plus interval 1 day thing, and then we said, okay, and then what's the actual next day? And for that, we use the lead function. All right. So it's really just like, there's like 3 window functions, right, that we're practicing with in one problem and a CTE. So that's why this is good practice. All right.